Hello everyone and welcome to .NET Core Central. In my last video, I discussed about state pattern and a state machine. And the state machine that I built is for car, where a car can have multiple state, and based on multiple action, the states of the car can change. And I created a simple state machine using a switch statement where based on different current state and an action, the car can get into a next state. And the main fundamentals of a state machine is the behavior of the object is changed due to the state. And this is something I discussed in detail in my last video. So I would encourage you to go and see it. But at a high level, as you can see, based on the change of the state of a car, it is going to behave differently. For example, when a car is started, it can go into the next state of running. But if a car is stopped, it cannot directly go into running. It has to be first started and then it can go into run. And similarly, the stopping a car is not going to have any effect if the car is already stopped. It will have an effect only if the car is started or running. And this is what we discussed in our last video. Today, instead of using a handmade state machine, which is very limited, and as you can see, if you have to manage a multiple state and much more complex scenario, there will be a lot of code that we'll have to deal with, and this is not going to be ideal for a handmade state machine. Hence, today I am going to talk about a .NET open source state machine called Stateless. And first, I am going to install the state machine from NuGet package, and this is the state machine. It's called Stateless, and this state machine is created by one of the lead developers of Artifact, which is one of the most famous dependency injection engine for .NET. So first I am going to install, and I'm going to install the latest version. And as you can see, it supports .NET Framework as well as .NET 5 and .NET Standard libraries. So I'm going to install it. And one good thing about Stateless Framework is it does not have any dependency apart from the core framework. Next, I'm going to the program class and the main method, and here instead of using the handmade state machine, I'm going to use the stateless. So for stateless, what we can do is we can create a new stateless dot state machine. And the state machine, as you can see, it's a generic class which takes two types. One type is the type of the state, and second type is the type of the trigger. So in our case, the type of the state is nothing but car dot state, and trigger is nothing but car dot action. And then what we can do is, for the constructor, there are four different options. First, we are going to talk about option number 1, which is the most common case, where we are going to pass an initial state. And then after going through some of the concept, I'm going to talk about the other overloads of the constructor. So let's start with the state of the car as stopped, just like before. So now this has created a state machine, and then what we can do is we can configure the state machine for different actions. So if we see here, we configured that when the state of a car is stopped, it can be started. When it's started, it can be accelerated. When it is started, it can be stopped. And when it is running, it can be stopped. So we're going to have similar configuration. And the other thing we did is for any other state, we'll just maintain the current state of the car, which is going to be a little different in the state machine implementation. So first, let's start with setting up different states. And for different state, what we can do is we can use something called configure. Configure is going to configure for a particular state. So we're going to say if state is stopped, then we want to allow start. And for that allow function, we use something called permit. And for the permit, we're going to say it can be permitted to start when a car is stopped. Acceleration is not permitted. And the state of the car will be changed from stopped to started. So that's the first thing we are going to do. The second thing what we can do is we can configure for the started state, meaning what all can happen when the car is started. So we can say car.configure and state is going to be started. And for started, what are the different things can happen? For started, the car can be accelerated. So we can say permit state dot accelerate. And when that happens, the state of the car is going to be running. The second thing what can happen is when a car is started, it can be stopped. So the action is going to be stopped and the state of the car is going to be going back to stop. So these are two actions we can do. And then finally, if the car is running, configure state, and we say if the car state is running, we can essentially stop the car. So we can say permit, and this action is going to be stopped and the state of the car is going to be stopped. So these are the things we can support. And then we want to print out the state just like the previous video. So for printing out the state, we have a property called state, which gives the current state of the state machine. So we are going to use that. Let me first change everything to state for all the console.write statement. And then for take action, which was the method which was part of the car, which will initiate the state machine, here there is a function called fire, and that is what we are going to use. So we are going to fire start again, fire accelerate, and fire stop. Now if we run this application now, it is going to fail because once a car is start, it goes to started, and if you fire start again, it does not know how to handle this. So let me first run it, show that it fails, then I'll comment this out, then we'll run it, make it working, and then I'm going to show how you can manage the same state to re-enter the state machine. So let me first run this application, and you can see that it is throwing an exception that destination state is not. So the error is coming because I set up the state as wrong. I'm setting the destination state and started state as same. It should have been started. So that's a code mistake. So let me fix that. Now run it again. And this time it is coming and failing here as we expected. It says not valid leaving transition are permitted. Stay started for triggering start. So it is saying that you already have what has to happen for start. So we don't know how to handle start. Consider ignoring the trigger, and we'll come back to that. This is a very important message, and what I have seen is the exception messages are very clear when it comes to this particular framework. It is done very well. So now let's run this after I commented the start again, and we can see that state is stopped, which is the initial state. Then after we trigger the start, it is started. Then we triggered accelerate, it is running, and then we trigger stop, it is stopped. If we want to enable start again on start, which is the state started, what we can do. And as I said, the error message said that we can use ignore. So use the ignore. So what we can do is we can introduce a case called ignore, and we can say if the action is start, then just ignore and keep the same state. And if I run this, after I uncommented this, we can see that we can start the car twice, because second time it is just going to ignore as the car is already started. And as we can see, it stopped, started, it just print out the current state because it ignored the start command. So this is how you can configure it to do that. There is another way of doing it instead of ignore. It's called permit re-entry. So here what we are saying that even if car was started, let start be triggered again through permit re-entry. So if we run this, we should see the exact same behavior. So you can see car was stopped, started again, and nothing happened because we said just permit re-entry for start action. So this is, as you can see, a very simple way of writing the same code, but it is much more powerful as we can do much more thing than just permit. So let's take into consideration of what else we can do. So one thing we can do is on entry or exit of a state, if we want to do some action, we can do that using another couple of methods. So one is on entry, and on entry essentially we get an action, and with the action, if I take the overload on an entry, so you can see the action is going to provide the state machine itself, using which we can print stuff out. So let's take that and say on entry we get the state machine, and for the time being we're just going to do a console.write line. So we can do console.write line $, and we can say entry, and we can print out the source state, which is what was the state when it entered, and then we can also print out the destination, basically what state it's going to change to. So in our case, the source state is going to be stopped and the destination state is going to be started. So that is what we can do. And on exit, we can do the same thing. So we can say on exit, and I'm just going to copy paste the same code because it is exactly the same, and just change this from entry to exit. And as you can see, I'm just doing console.writeLine here, but you can do a lot of logic on entry and exit if you want to do during state transition. So what I'm going to do is I'm going to get rid of this fire start again. It is not needed. Let's run the application now. And when we run the application, we can see that during entry it was stopped. That was the previous state. Then we did a start, so it got triggered first time. So it comes and we start here. So then it says before it execute changes the state, it was stopped, and then it started, and then it started. And during exit, what has happened is, as you can see, we did the accelerate, and accelerate is going to change the state to running because that's the going out state from started. Earlier it was stopped and then we changed it to started. Now since we fired the accelerate, now it is going out of the started state. So it will say during exit, now the exit will fire, and during exit it will say my state was started, and after the exit it is going to go into running. So that's how entry and exit can be explained in this case. So that's another pretty cool feature. The other thing we can do is we can trigger a function when a particular state is changed if we want to handle the state transition but we don't want to change the state. For example, when a car is running and if a start is called again, we don't want to change the state of the car, but we might still want to handle the call. So for that, what we can do is we can use something called internal transition. And as you can see, all this function has an async as well. So we can use async variety also if we are dealing with asynchronous call. And we can also use something called transition if or transition async if, which is essentially transition along with a Boolean condition which will decide whether it will be fired or not. We're just going to use the internal transition. And for the state, we are going to say if it is start, right? Because during running state, if it is started again, then what we can do is we can say if it is start, just execute an action, and you can see it takes an action. It takes different overload of action, so we can use any of the overload, but for this example I'll keep it simple, and I'm going to say console.writeLine start called while running, and then I'm going to call the start again after it's been accelerated, which means the state is running. And here you can see that it is saying that start called while running. Because we call start again, it triggered this internal transition and it just performed an action on it. So this is another very cool feature that we can use. The other thing we can do is, for example, running is nothing but a state of started. It's essentially can be considered as a substate of started. So we can do something like dot substate of, and we can say running is a substate of started. And if we do that, then we are just attaching the two state. Now the behavior for this should not change when we run this application, but this is a very handy feature if we want to handle substate and parent state. The other very important thing that state machine supports is a way to pass parameter, and that is something I touched upon briefly before. So there might be a situation where you might want to pass a parameter while triggering a particular event, and that is something we can do. So let's say we want to do something when a running state is entered. So what we can do is we can create var trigger with param is equal to car.set trigger with parameters, and parameters, as you can see, it's a arg, so it can be multiple, and here we can support up till 3 types of argument. For this example, we're just going to have one, which is int, and for the action we are going to use accelerate. So we're going to say when you call accelerate, you can pass a parameter. So what we are going to do is, where we are calling the accelerate, instead of calling accelerate, we are going to pass this trigger with parameter, and then here, as you can see, we can pass an param object array, and here I'm going to say 50. So accelerate to 50, that's the parameter, 50 miles per hour as a parameter. And then what I can do is I can have here when the car is running, and how the car is going to run if acceleration is triggered. So we can say on entry from, and on entry from we can say trigger with parameter. If it is entering from this trigger with parameter, then, and as you can see, it takes an action, or in the overload, as you can see, it takes an action with the state machine or action with the trigger parameters, as you can see here. So we are going to use the trigger parameter, and here we can say speed, and I'm just going to just do a console.writeLine and say speed is speed. That's all I'm going to do. And now if we run this application, we should see that after the state change to started, while running, when someone started the running, we can see that we got the speed of 50. So this is how we can use a parameter and do some logic with the parameter using entry from. And for the permit, there are a couple of other overload, which I'm just going to show you, but I'm not going to do any code for that. Is something called permit if, and permit if is nothing but similar thing. You have a trigger and an action, but essentially you can pass a func with bool, which will decide whether to permit this action or not based on this bool condition. And as you can see, the GERT can be param, which means you can have multiple conditions, but more than one condition cannot be true at the same time. So I'm not going to show this. The next important thing about any state machine is, can I keep my state in an external storage? And it becomes very important when you have a state machine which can be scaled, or which needs to be scaled across multiple services. Now, Stateless provides a way to do that, and the way you do it is, while you create a new state, you can have the other overloads, and the overload that we can use here is this overload which takes a func of state accessor, which returns a state, and an action called state mutator, which takes a state and it can mutate. That is the whole goal of these two delegates, one func, one action. So you can return a state from an external storage, and you can update the state into the external storage every time a state change happens. And to demonstrate that, I'm not going to create an external storage or anything, but I'm just going to create a simple variable here, using which I can show that the variable is getting updated, which is same as updating an external store. It's just that you will have some SQL code or a MongoDB code or a DynamoDB code or a Redis cache code to update your state into an external storage. So I can say external state, and I'm just going to set it as, that's the initial state. And then here I can say, in the first case, I can say return the state from external state. And for the mutation, I'm going to take the state and I'm going to say external state is equal to state. That's all. And then I can come here and I can update all my console.writeLine to external state, just to show that it's going to reflect the exact state of the state machine. And now if I run this, the application should behave exactly same, and you can see it's behaving exactly same. The state is printing from the external storage now. This is of course one of the most important feature, because if you're not able to save state externally, it's impossible to scale a service which is using this state machine. The next important feature is events. So what we can do is we can use some of the events which is provided by the state machine, and the events are on transition completed, which will get triggered after all entry form and other methods are invoked. On transition is very similar to on transition completed, but in case of on transition, it will not consider things like on entry form. It will trigger as soon as the transition is done. And the final one is on unhandled trigger, which overrides the default behavior of how to handle an exception. So I'm going to just show the on transition. And in on transition, we get an action with the transition of the state machine. So we can say transition. And I'm just going to do a console.write just to show what happened. So we can say console.write line and transition, and we can do t.source, t.destination. That's pretty much it, just to show how it works. And we'll see that after every transition it will print out the state transition. For running, it will print it once because we call the running twice, but from stop to started, from started to running, and then running to stop, you can see all the three transitions are printed out as expected. And last but not least, it also has few functions which can be used. For example, card.one function is called getInfo, which gives the entire state machine info, and it has basically property like initial state, all the states, the type of the trigger, the type of the state. And then similarly, there is another method which is called getPermitted_triggers, which gives all the triggers that there are. And last but not the least, there is another function which is very useful, which is called isInState, which says if the state that is supplied is the current state or not. And I think it's very useful. And like for here, for example, at the end of it, if we say card.state.running, and if I just say console.write line, it should return a false because the current state is stopped. So let me just run the application, and we can see that yes, it returns false as expected. So these are the main functions and methods that we can use as a part of the stateless state machine. And as you can see, it's extremely powerful. You can save the state externally into any storage of your like, making this to be able to scale horizontally. It has events which can be captured to do some action, post-event action. Apart from permit, there is an option of re-entry, there is an option of ignore, there are on-entry, on-exit method, and then there are internal state transition method which allow you to handle a action but do some custom logic of what you want. It also supports trigger with parameter, and then the triggers with parameter can be handled through on-entry from, and we can deal with the parameters whatever we want to do. So I think it's a very powerful and useful state machine. That's all I wanted to cover for today's video. If you like this video, please give me a thumbs up, and if you are new to my channel, if you think you are getting value out of my channel, please subscribe to my channel. And thanks so much for watching this video.